Okay, y'all, in this lesson, we're going to learn how to multiply and divide in scientific notation. So multiplying numbers in scientific notation behaves like multiplying like variables. So for example, if we have let's say 2a to the third times 5a to the fourth, we would multiply the 2 times the 5 and get 10. And then we have the same base raised to an exponent, and we would apply the product rule and add 3 plus 4, which is 7. So scientific notation is similar in that our coefficients are multiplied, just like the 2 and the 5, so 6 times 4 is 24. And then we have powers that have the same base, so we write the base down and we add exponents. We're using the product rule. Now, before we're finished, we have to ask ourselves, is this in proper scientific notation? Is this coefficient between 1 and 10? It is not. And therefore, I have to modify this. So I need a decimal to be between the 2 and the 4. Let me erase that and write it below. So I want my coefficient to be 2.4 because this is proper scientific notation. Now, because we adjusted the coefficient to keep it balanced, we have to adjust the exponent. So I went from 24 down to 2.4. Therefore, I have to keep it balanced and go up an exponent on my power. And 24 times 10 to the 7th is the same as 2.4 times 10 to the 8th. But this is proper scientific notation. Okay, let's try these together. So again, at any time you need to pause the video, please pause. So let's write our first problem. So we're going to multiply this scientific number times this scientific number. So we multiply your coefficients, 8 times 3 is 24, times 10, and I have 10 to the negative 3 times 10 to the positive 7. So I'm going to add my exponents, negative 3 plus 7, and this gives us 4. Now again, this is not in proper scientific notation. This 24 needs to be 2.4. So I went down in value here, so I need to go up on my exponent. So if I moved my decimal one place, I increase this exponent by 1. Our next problem, we have 1.5 times 2. Remember, we can't use a calculator for this unit. So we get 3 times 10, and we are adding exponents using the product rule, and this gives us 6. Now 3 is between 1 and 10, so I don't have to make any adjustments. The next one, we have 4.2 times 2, and we're going to multiply. 2 times 2 is 4, 2 times 4 is 8, and I have 1 decimal place, so we get 8.4 times 10, and I need to add these exponents and get negative 9. Then we ask ourselves, is 8.4 between 1 and 10? And it is, so I do not need to make any adjustments. And our last example, 2.4 times 10 to the negative 8 times 4 times 10 to the positive 1. I'm going to go ahead and write in that understood 1. So we're going to multiply coefficients. 4 times 4 is 16. 4 times 2 is 8, plus 1 is 9, and it's 1 decimal. So we have 9.6 times 10. Negative 8 plus 1 is negative 7. My coefficient is between 1 and 10. It's in proper notation, so no adjustments. Okay, pause the video, and then when we come back, we will go over these together. Number 1, our coefficient, 7 times 5 is 35 times 10. We use the product rule to add our exponents. 35 is not between 1 and 10, so I need to move my decimal one place. So I went from 35 to 3.5, so I went down on the left side. So we need to increase this exponent to a 3. Number 2, we have 2.5 times 3, 15. 6 plus 1 is 7, so we get 7.5 times 10. We're going to add exponents using our product rule. 7.5 is between 1 and 10, so we're good to go. Number 3, we have 1.2 times 4. 4 times 2 is 8. 4 times 1 is 4, so we get 4.8 times 10. We're going to add exponents. We get 5 plus -8 is -3. 4.8 is between 1 and 10, so no adjustments needed. Number 4, 8 times 7 is 56 times 10 to the -5 plus 2 is -3. 56 is not between 1 and 10, so I need to move my decimal once. So I decrease from 56 to 5.6, so I need to increase on the right side. Now, be careful, we're increasing a negative. So negatives are opposites of positive. So to increase -3 by 1 puts us at -2. So be really careful with your negatives. Okay, so dividing in scientific notation, again, behaves like variables. So if we had, let's say we have 8c to the 5th over 2c to the 3rd. We would divide our coefficients and get 4. We would apply the quotient rule and subtract our exponents, 5 minus 3. So that was 5 minus 3. This gives us 2. So this is very similar. We will divide our coefficients and then we will apply the quotient rule for our like bases. We will subtract our exponents. So 6 divided by 2 is 3 times 10, and we have 5 minus 3 gives us 2. Our coefficient 3 is between 1 and 10, so we're good to go. So let's practice these 4 together. Again, pause the video at any time that you need to write the problem down. Our first one, we have 9 divided by 3 is 3 times 10. We're going to have a 5 minus -3, so be careful. And then we can do keep, change, change, and we get an exponent of 8. Our next problem, we have 4 divided into 1.2, or 1.2 divided by 4. Whoops, that needs to be a 3. Got a little ahead of myself. Okay, so let's go through long division. 4 could not go into 1, I put a 0, but 4 can go into 12 3 times. So my coefficient is 0.3 times 10. I'm going to subtract -2 minus 6, keep, change, change, I get -8. Now, 0.3 is not between 1 and 10, so I need to increase and move the decimal to the right. So I increase my coefficient from 0.3 to 3. So I decrease my exponent, and I have to be careful when I'm decreasing negative numbers is the opposite of positive. So going down 1 from -8 is -9. Our third example, 3.6 divided by 9, or 9 divided into 3.6. 9 can't go into 3, but 9 can go into 36 fours. So this gives us a coefficient of 0.4 times 10. Then I have 2 minus -8, keep, change, change, an exponent of 10. 0.4 is not in proper notation, scientific notation. It's not between 1 and 10, so I need to move the decimal. So I increase the coefficient, so we have to decrease the exponent. The last example, 2.4 divided by 1.2 or 1.2 divided into 2.4. We need to make this a whole number, so I'm going to move it over, make it a 12, and I also have to move this decimal. And so I really have 12 divided into 24, which goes 2 times. So I have 2 times 10, -1 minus 9, keep, change, -10. Our coefficient 2 is between 1 and 10. I'm good to go. Okay, pause the video, and then when we come back, we'll go over these. Number 1, we have 6 divided by 3, or 3 divided into 6 is 2 times 10. -2 minus 3, keep, change, and I get -5. 2 is between 1 and 10. I'm good to go. Number 2, 1.8 divided by 3, or 3 divided into 1.8. 3 can't go into 0, but it can go into 18, so I get 0.6 times 10 to the, subtract -4 minus -2, keep, change, I get -2. 0.6 needs to be increased to a 6, because this is not between 1 and 10. So I increase the left, so we're going to decrease the right, and we get -3 as our exponent. Number 3, 3.2 divided by 4, or 4 divided into 3.2. That gives me 0.8, so 0.8 times 10. We have 7 minus -3, keep, change, and I get an exponent of 10. I need to adjust the 0.8. It needs to be between 1 and 10, so let's make it 8, move the decimal over 1. So I increased on the left, so we need to decrease on the right, so I decrease by 1 exponent because I only moved the decimal once, and that gives us 10 to the 9th. Our last example, 3.6 divided by 1.2, or 1.2 divided into 3.6. Move our decimal. So 12 into 36 goes 3 times. We have 3 times 10 to the 5 minus 5 is 0. Anything raised to the 0 is 1, so 3 times 1 is just 3. But if you want to leave it as having a base, you could leave it 10 to the 0, but 3 is the most simplified answer. And I hope this helps.